This calculation is an activity question. It's question 11 from page 90. I'll first read the question to you. It's a combination circuit with capacitors in series and in parallel. Two capacitors of 50 microfarad and 30 microfarad are connected in parallel. This parallel combination is then connected in series to a 10 microfarad capacitor. The circuit is connected to a 75 volt DC supply. Now, before we look at the questions, I just want to highlight this formula we'll be using to calculate the electrical charge. The units is in coulomb, and it will be C multiplied by V. C is the capacitance in farads, and V is the voltage in volts. Now, one other thing I want to point out, when you have capacitors in parallel, you add the capacitance up like they are resistors in series. For a parallel branch, voltage stays the same. However, for the capacitors, we will have separate charges for in coulomb across the parallel branch. When you have capacitors in series, if you add up the capacitance, you treat them like they are resistors in parallel. Voltage is divided in a series circuit. However, the charge remains the same. Alright, so let's have a look at that. So the first question, we need to calculate the total capacitance of the circuit. So I've gone ahead and drawn the diagram. So we have capacitor 1 and capacitor 2 in parallel. And this parallel combination is in series with the third capacitor, and the supply voltage is 75 volts. Right, so let's go ahead and calculate the capacitance in the parallel branch. So the capacitance in the parallel branch will be C1 plus C2. C1 is 50 microfarad plus 30 microfarad. Now for consistency, I'm going to work with the same units. So we're going to end up with 80 microfarad. Now that's the parallel branch. So to calculate the total capacitance, we have two different categories over here. We've got this parallel branch, and then we've got our third capacitor over there. Now, capacitors in series behave like resistors in parallel. So what I'm going to do is I'm going to use the product sum rule. So it's going to be the capacitance of the parallel branch multiplied by C3 over the capacitance of the parallel branch plus C3. So we're using the product sum rule here. So it's going to be 80 multiplied by 10 over 80 plus 10, and this will give us our capacitance total in microfarad, and the answer we get here 8,889. Always round off to 3 decimal places. Now in the next question, we need to calculate the potential difference across each capacitor. So we're going to have a volt drop across this branch, which is C3, so we can call that V3. Then we will have a volt drop across the parallel branch, and we can call this V parallel. Now the total voltage, let me make a note here, the total voltage is equal to V parallel plus V3. Alright, so to calculate the potential difference, what I'm going to do is, let's just take a look. We say V3 will be equal to the charge total divided by C3. Then once we've got V3, it will make our lives a lot easier. So let's go ahead and calculate that. Now you'll notice that we don't have the total charge, so we're going to have to calculate the total charge. Let me just use a different color here to help us. Okay, let's use blue. Alright, so to calculate the total charge, it will be equal to the total voltage multiplied by the total capacitance. The total voltage is 75 volts, and the total capacitance from the previous question is 8,889 microfarad. So therefore, my answer will be in microcoulombs. Okay, so we'll leave it in micro. So the answer we get here will be 666,674 microcoulomb. Alright, so we can substitute that in here. to work out that volt drop across the third capacitor. So we get 666,674. It is microcoulomb. And the capacitor is 10 microfarad. Now, as you can see, we've got the same units over there, so they will cancel each other out, and we end up with a volt drop of 66,668 volts. Right, now that we've got that volt drop, we can actually go ahead and start to solve. So now we can actually calculate V parallel. So V parallel will be the total voltage minus the volt drop across the third capacitor. So therefore, the total voltage of 75 minus 66,668. And so the parallel branch is going to be 8,332 volts. Now remember, voltage stays the same in parallel. So we've solved for the volt drops. Right, the next question, we need to calculate the charge across each capacitor. Now, I just want to point out to you, in the earlier slide, I said that in parallel, the charges are different, but in series, the charge stays the same. Our Q over here, Q3, is the same as Q total. Okay, let me make a note of that again. So the charge for the third capacitor is the same as the total charge. So that is 666,674 microcoulomb. All right, we've already calculated that in the previous question. Right, now to calculate the charge number 1 and to calculate charge number 2 using our pyramid. Now remember, voltage stays the same in parallel. So it's V parallel times C1. V parallel times C2. Okay, so let's substitute our voltage here for the parallel branch. Capacitor 1 is 50 microfarad. So our answer will be in microcoulomb. So it's 416,6 microcoulomb. Voltage stays the same in parallel. 8,332 times 30 microfarad. So our answer will be a microcoulomb. Okay, thanks guys. Thanks for watching this video.